To solve this system of equations, label these equations 1 and 2. We'll solve this by eliminating the term with a variable. In this case, we'll multiply equation 1 with 2 and add it to equation 2. So equation 1 becomes, after multiplying with 2, becomes 6xy minus 4y squared equals to negative 4. And add this to equation 2, which is 9x squared plus 4y squared equals 10. When we add this, we'll have 9x squared plus 6xy, negative 4y squared and positive 4y squared is cancelled. And so you have this equation equals to 6. So we have 9x squared plus 6xy equals to 6, which is equivalent to 3x squared plus 2xy equals to 2 by dividing this equation throughout by 3. From this equation, we'll isolate y. And so we have 2xy equals to 2 minus 3x squared. By isolating y, we have y equals to 2 minus 3x squared divided by 2x. We'll use this value of y in equation 2. Equation 2 is 9x squared plus 4y squared equals to 10. And so we want to use y here. So you have 9x squared plus 4 times 2 minus 3x squared over 2x squared equals to 10. We'll try to simplify this equation as much as possible. And so we'll write 9x squared plus 4 times, we'll try to expand the squared term. This becomes 4 minus 12x squared plus 9x to the 4 in the numerator, and the denominator will be 4x squared equals 10. Cancel out 4 and 4. And so you have 9x squared plus 4 minus 12x squared plus 9x to the 4 divided by x squared equals to 10. And so we can multiply throughout by x squared in order to knock the denominator off. And so you have x squared times 9x squared plus 4 minus 12x squared plus 9x to the 4, all of this divided by x squared equals to 10 times x squared. And so when you distribute this multiplication, we'll have 9x to the 4 plus 12 minus x squared plus 9x to the 4 equals to 10x squared. This is equivalent to writing 9x to the 4 minus 11x squared plus 2 equals to 0. Now we have a quadratic in x squared. So we can factor this as shown here. 9x squared minus 2 times x squared minus 1 equals to 0, which gives us x squared, 9x squared minus 2 equals to 0. or x squared minus 1 equals to 0, which means x squared equals to 2 nines, which means x equals to plus or minus root 2 over 3. And from here, x squared minus 1 equals to 0 gives us x squared equals to 1 and x equals to plus or minus 1. Now we'll back substitute the values of x we obtained in equation 3 and find the value of y. Now equation 3 is y equals to 2 minus 3x squared divided by 2x. This is the y value we obtained after eliminating the y squared term in the beginning. So we labeled this equation 3. And so we want to use each one of these x values to obtain the y value. When x is root 2 over 3, y will be y equals to 2 minus 3 times root 2 over 3 squared divided by 2 times root 2 over 3, which gives us 2 minus 3 times 2 over 9 divided by 2 times root 2 over 3. And so this becomes y equals to 2 minus 2 over 3. By cancelling out the common factors here, 3 goes in 9 3 times, and then you have 2 times root 2 over 3, which is equivalent to writing 3 times 2 minus 2 over 3 divided by 3 times 2 times root 2 over 3. And so we can further simplify this as y equals to 6 minus 2 divided by 2 root 2, which is 4 over 2 root 2, which is 2 over root 2, which implies y is root 2. Similarly, we can obtain the value of y when x equals to negative root 2 over 3, in which case y would be y equals to negative root 2. Now we'll obtain the values of y when x equals to 1 and when x equals to negative 1. When x equals to 1, y is equal to 2 minus 3x squared, which is 3 times 1 squared, divided by 2 times 1. And so this gives us 2 minus 3 divided by 2. This is negative 1 over 2. Similarly, when x equals to negative 1, we'll obtain y equals to 2 minus 3 times negative 1 squared divided by 2 times negative 1, which gives us 2 minus 3 divided by negative 2, which is positive half. And so for each one of these x values, we have corresponding y values. And so we'll write these values one at a time. Root 2 over 3 gave us the y value of root 2, and negative root 2 over 3 gave us the value negative root 2. Similarly, 1 for x gives us negative half, and negative 1 gave us what? Half. And so we have all these points of intersection of these two functions.